use these resources, which support the world's energy needs. Weir Oil and Gas serves both the upstream and downstream energy industries. Most of the company's products and services, including valves, pumps, frac trees, manifolds, and other flow control equipment, help upstream customers to safely manage the fluids they use under incredibly high pressures. In the first phase of drilling unconventional wells, like the one in this shale gas formation, they are drilled like any other. As the drill bit grinds the hole, a mixture of water, sand, and additives called mud is pumped into the wellbore. Mud helps keep the drill bit from overheating and flushes drill cuttings to the surface. It also lines the walls of the holes to prevent blowouts, prevent the wellbore from collapsing, and protect the surrounding formation. Most wells are at least 6,500 feet deep. Some plunge up to 15,000 feet into the earth. This is far below usable groundwater aquifers. Several layers of protection help isolate the well from any freshwater zones. When the hole reaches the right depth, the drill bit is removed and steel surface casing is inserted to protect the well at shallow depths. Cement forms another protective barrier while adding stability. The cement is pumped down the casing and out through the bottom opening. With nowhere else to go, it is forced up into the space between the casing and the wellbore wall. This completely seals off the formations, preventing fluids from migrating up or down the hole. All this cement is pumped with an SPM cement pump through a Mesa cement head and manifold. After this first cementing phase, the pipe and bed are lowered back down the hole to continue drilling. The target is the precise spot where geologists believe the well can tap the reservoir for optimal production. At the kickoff point about 500 feet above the planned lateral leg, sophisticated measuring while drilling instruments are lowered into the hole to drill the precise curve and the lateral leg of the well. When the bit reaches the target, the crew runs steel production casing into the wellbore, lining its full length. As before, cement is pumped down the casing, out through the bottom, and up into the open space between the casing and the wellbore wall. This creates a barrier between the well and the surrounding formation for the entire length. With the final casing string in place, the drilling rig leaves the site. A Seaboard manufactured wellhead, or Christmas tree, is installed. The next step is to perforate the well. The crew lowers a perforating gun into position near the end or toe of the horizontal leg. The gun detonates minor explosive charges to shoot small holes through the casing and cement sheath. These holes will ultimately serve as portals that allow natural gas to pass from the reservoir into the well. But in an unconventional well, the holes must first be used to hydraulically fracture the rock before a single drop can flow. Hydraulic fracturing, or fracking, may be the most important energy technology today. Imagine picking up a pebble from the ground. Even though it may be saturated with hydrocarbons, no oil seeps out into your hand. You can't squeeze anything out. It's the same with oil and natural gas deposits in impermeable formations. Most people think of oil and gas reservoirs as being like underground ponds. In unconventional reservoirs, however, hydrocarbon molecules are trapped within the pores of the stone. Hydraulic fracturing uses highly pressurized fluids to create controlled, hair-thin fissures in the rock. Oil and gas can then escape through these passages and flow into the wellbore. Using hydraulic fracturing to produce unconventional shale gas, shale oil, coal bed methane, and tight gas is relatively new. But fracking has been used safely in conventional wells for over half a century. A frac site is an amazing concentration of power. It takes extreme pressure to crack a rock. Frac pressures can ramp up to a bruising 15,000 pounds per square inch. Up to 40 high-pressure pump trucks may team up on a single site. Each pressure pump uses up to 2,500 horsepower to jet a combined 100 barrels of fluid a minute into the well. This is where SPM pumps, other flow control products, and Seaboard frac trees shine. Only the most rugged, well-made equipment can endure such extreme operation. To start the frac process, water flows from the water storage area through the WSP water suction pump and into the blender. The blender unit mixes the water and propant before sending it to the Hazelton slurry discharge pump. The slurry discharge pump transfers the fluid and propant mixture to SPM safety iron manifold trailers, which are customized for the customer's needs. The manifold manages the flow of frac fluid through the frac pumping units, situated next to the trailers. SPM offers multiple frac pumps to meet customer needs, including the latest design, the SPM Destiny QWS 2800. From there, SPM Flow Control Products direct the high-pressure frac fluid to the wellhead. These flow lines connect to other Weir products, the Mesa frac head, which connects to the Seaboard frac tree. On a frac site, high-pressure flow lines could be lethal if they become loose or rupture. To prevent this, SPM offers the award-winning Flow Line Safety Restraint System, or FSR. This acts almost like a bungee cord to secure high-pressure flow lines. Although extreme high pressure must be handled with the proper care and equipment, it is essential to successful fracking. The pressurized frac fluid passes through the frac head, down the sealed well, and through the perforations already placed at the bottom. As the fluid presses against the targeted rock, pressure builds. Microscopic fractures begin spreading through the rock. Frac fluid sweeps the sand or other propant particles into these tiny cracks, literally propping them open so that gas can flow into the wellbore. A temporary plug is placed in the wellbore to isolate the fracked section. This will prevent pressure loss through the perforations during the next frac stage. The perf gun runs through the well again, creating a new set of perforations. This section is fracked as well, and then isolated with another plug. This frac crew repeats this process 8 to 12 times at up to 300-foot intervals, covering much of the horizontal leg of the wellbore. A permanent seaboard wellhead with blowout preventer caps off the well. A pipeline is then built to transport the natural gas to market.